Question 1 on the practice exam is a one-way ANOVA test, and we're testing sensors that are detecting water leaks, and we are looking at 4 different valves, and we're sampling 10 of each of those valves. So altogether we would have 40 items in our group, and we have 2 hypothesis statements. The null is that all mu's are equal between these 4 valves, meaning the average time to detect a water leak is the same for all 4. And the alternative is that not all are equal. Our alpha value is 0.05 for this test that we'll run. So let's take a look here now at what our table is. And so what you see here is the table. Looks very much like the one that we would get out of Excel, only we're missing some values, so we need to fill in what these are. Now just keep in mind with a table like this, all you're doing is adding and subtracting basically to figure out what these are and knowing some rules about that. So the first thing is saying, what is the sum of squares within groups? Remember, in these tables everything should add up. So if we've got this value here, 991, 775, and 709, 475, the difference between those is going to be our sum of squares within groups. So if you subtract 709,475 from 991.775, we get 282.3. So 282.3. Okay? So then these will add up to 991.775. Degrees of freedom. If you recall, we have 4 valves, right? So the 4 valves minus 1 for our degrees of freedom. We have 3 degrees of freedom here for the between groups, each of the 4 valves. And then within groups, again, these should all add up here. So if we say 39 minus 3, this will be 36. But the other way to look at that is that we have, if you recall, n equals 10, and so for each group, so we have 4 groups, is 40, and if our degrees of freedom for each is n minus 1, it would be 9 times 4, which would be the 36 right there. So that's another way to look at it. Alright. But just know in the end that those should add up. If they don't add up, you've got something wrong. Now, when you do the mean of squares for each one, you're just going to divide. In this first case here, I'll just circle this. The 709,475 you'll divide by 3. Okay? So that will be 236. We'll say 0.49. And then we do the same thing here for the 282.3. We divide that by 36. So you divide each by the degree of freedom, and you get 7.84. Alright. Now then, to get the F value, let's just move this over a little bit. We won't be concerned with the P value. So F, our F statistic, is going to be 236.49 divided by 7.84. And for that we get 30.16. Okay, so now we've filled in the table and we've got the answers here. So sum of squares within groups was the 282.3. Degrees of freedom between groups is 3. Remember, the 4 valves minus 1. Degrees of freedom within groups is 36. And the mean of squares between groups is 236.49. Mean of squares within groups was 7.84. And the calculated F statistic is 30.16. So the final question, or the final question on this part, is based on your calculations, you will reject or not reject the null hypothesis. Now here we find the critical value for F, so F of alpha is equal to this right here, 2.866. Because our calculated F statistic is greater than the critical value, we will reject the null, and we will conclude that all the valve, the mean time for it to detect water leaks is not the same between among the 4 different types of valves tested. All right, so that's the first part. Now we've got some other questions to think about here. Once we've rejected the null, that means we need to, then the next step would be to say, okay, we know that they're not equal. So if we look back here at our hypothesis statements, we said in the null that they're all equal. We've rejected that, and we're saying, no, they are not all equal, but which one or ones are not equal? How do we know which ones are different? So that's the next part of the test. So when you reject the null in this case, then we would conduct something called the Tukey-Kramer test, and that's the next part of the question here. And to do that, we've got this table and a formula to fill in to conduct that. All right, so to do this, let's look now at this formula. We've got a Q value, Q for our alpha value, and then we need the mean squares within value divided by 2 and divide by 1 over n plus 1 over ni plus 1 over nj. So basically what we're going to do is we're going to compare each value. So we've got along here, we've got each set of comparisons, valve 1 versus valve 2, valve 1 versus valve 3, and so on. And the difference between each of x bar 1 minus x bar 2, and that's shown here. So in some cases we got a negative value, in some cases we have a positive value. And then we take the absolute value over here, which basically just eliminates any negatives there, and we're comparing all positive values in that column, in the second column. All right, so first of all, what we have to do is find the critical range for this, and this is a confidence interval kind of a question. So we're saying if it's going to be greater than a certain value, then we will conclude there's a difference between, in this case, depending on valve 1 and valve 2, valve 1 and valve 3, and so on, right over here. All right, so that's kind of just setting up what we are going to be doing. So let's go back here and get this value. So we know in this case, before we do that, n is going to be 10 in all cases. So we only need to calculate the critical range once because we have equal sample sizes between our 4 valves. So that's good. It makes this a little bit easier. If you had different sample sizes, you'd have to put in the proper n value for each of these comparisons. Luckily, we don't have to do that here. So let's now go back here, and the mean squares within was 7.84. All right. So let's come back here and we'll do this part of the problem right now. So we have Q of alpha was given as 3.82, and we'll times that by 7.84 over 2 times 1 over 10 plus 1 over 10. Okay, so if we do that, then our value becomes, for our critical range, the result of this is going to be 3.3827. All right, so let's go back over here. Okay, so we said our critical range is 3.3827, and that's as a result of calculating this equation right here. Okay, so now that we've got the critical range, here we compare that value to each of these. So if this value, if this value, the absolute value, is greater than this, we would say then that it's a significant difference. If it's less than that, we would say it is not a significant difference. So here we would say on this first one, valve 1 versus valve 2, there is a difference, but it's not significant. 1.5 is less than 3.3827. 10.9 is greater, so we would say yes, there is a critical, statistically significant difference there. No on valve 1 versus valve 4. Yes on valve 2 versus valve 3. No valve 2 versus valve 4, and yes again on valve 3 versus 4. Okay, so our critical or our statistically significant differences are here, here, and here. Alright, based on our answers above, valve 1 takes longer or shorter on average than valve 3. Well, the first thing we have to look at here is valve 1 and valve 3, was that a significant difference? So the answer there is yes, it's significant. And then we can look here, so again, this 10.9, the absolute value was greater than our critical range. So we say that's a significant result. Now it's saying, based on our answers above, valve 1 takes longer or shorter than valve 3. So when you say valve 1, X bar A minus X bar B, this would be 1, this would be valve 3. 1 is less than 3 because of the negative value here. So we would say on average, we can say it's statistically significant result that it takes shorter. We could say that conclusively based on our test.